Yep, all right, here we go. So we're back, and we just wrapped up talking about what makes data linear in a table, and we found the two slopes here for these two, and we've determined that these two are not lines. Watch the previous video if you're not sure how we figured that out. Right, Johnny?
Yup.
Tell them. So here in number 29, we found the slope, and what we're going to do is review some stuff that we did last night for homework. Let's go ahead and full screen this. So let's review last night what we did for homework. So last night what we did for homework was not only did we try to find out if the data was linear, but we tried to take the table, and once we found a slope, we tried to make it into a line. So what were the two different ways that we were able to write a linear equation? Point slope form, so we have point slope. Thank you, Preston. And standard form we do have. I'm just going to write that up here. Standard form. Standard form I want to wait on. Okay, it is a form. It is the third form.
Isn't it y equals mx plus b?
Yeah, y equals mx plus b is slope intercept form. So we saw this last night in the video. If we watched it, if we didn't, that's okay. We're doing it now, and we're going to be fine. So here we're going to take. We'll just cover that up right there. So we have point slope form and slope intercept form. Does anybody know what point slope form? I heard Sarah say that slope intercept form was y equals mx plus b. And point slope form? Raheem? Okay, now y2 minus y1 equals over x2 minus x1 equals m, right? That's how we find slope. But, Raheem, you notice something that I noticed too, and somebody else is going to tell me a different form, and I'm going to write it right underneath, because we're really not that wrong here. Somebody with a different equation. Yeah, Sarah.
Y minus y1 equals m in parentheses x minus x1.
Oh, it's red. Now it's green.
So y minus y1 equals m times x minus x1. See, I can edit that out, don't worry. Now, the thing I want to point out, Raheem, is you're not totally wrong. If you remember this slope formula, you're in good shape. Because actually, if you take this here, x2 minus x1, and multiply it on both sides, again, it's a little algebra trick. Multiply it on both sides, it cancels here, but what we do to one side, we must do to the other. So we know that in every line, like y equals mx plus b, we're going to fill in values for m and b, and we're going to leave our x and our y just as x and y, right? So let's look here at this equation. So if we look now, what we have here, after we multiply to both sides, is essentially this. If we just take our y2 and x2 and say, you know what, we're going to leave those as x and y. Okay, Raheem, so we don't need to memorize this formula. If we know what slope is, if we can come up with this slope formula, we don't need to memorize this point slope. Because it's already existing here. We just need to remember that we don't use 2 points. We just use one. We use 1 point and the slope. Here we use the slope and the intercept. But when we're just using that 1 point, we get to choose which one. And that's the beauty of seeing a table, is in this line, how many points did they give us? 4. We have a choice. Here we need only 1 point and our slope. We already found the slope here. We already found the slope there. Now we just need to pick a point. Does it matter which one we do? No, let's do a couple just to verify. So we're going to start with point slope form. We know our m is 4. Okay, our x1, let's pick a point to use. Somebody pick a point. 515, we'll start with the hardest one. Well, I don't know if it's the hardest one, but it's the biggest, so I'm just going to assume it's the hardest. So 515, and what's my x value here? So it's going to be x minus, again, remember we want to leave x as it is, and it's going to be x minus 5. And then here we have the equal sign again. I'm keeping everything straight down in line here. So that's y minus what on this side? 15. Well, you might be saying, look, oh, we have a linear equation. We do. But do we know what that looks like? Is anybody, if I gave you this, would you know, say, hey, that looks like a line?
No.
Like, Mr. F, you're crazy. That doesn't look like a line. It doesn't look like a line at all. What are we used to a line looking like? We're used to a line looking like this probably, right?
Yeah.
So how, okay, Allie, great idea. How are we going to simplify it, and what do you mean?
Well, first you distribute 4,
First we distribute 4, good.
Yeah, I think
and then you have y minus equals 4x minus
Minus 20, very good. Now what? One more thing to do. What's the difference between this form here and this form here? Is that what do we have is y all by itself? So what's the last thing I need to do, Allie?
you need to add 20 or 15.
Right, add 15 to both sides. You could add 20 to both sides. That wouldn't be wrong.
No, it's
But we just want to make sure that we're isolating this y. So here we have this. 15s go bye-bye. And what are we left with the guy on the right? We have 4x minus 5. So now we know what? Now we have this table which doesn't give us our y-intercept, but now we have an equation that does, and we know just by looking at the equation what's our y-intercept. -5. So for you guys that don't know, this b, because again this is y equals mx plus b, that -5 is our y-intercept. So what's the point that corresponds with that b being -5? What's the point? 0, -5. So if I had to add a point in my table, it would be 0, -5. And some people do it like that, okay? And I just want to point that out. Some people actually make the equation like that. So if they come here, they might extend the table the other way. For example, here the pattern was 1, right? Every time we added 1 going down the table, we added 4 going down the table for the y, right? So let's do it the other way. What if we put a 1 here? Then we would subtract 1, and what would we have to do with the 3? We would have to subtract 4, and we would get 1, -1. And then if we wanted a 0, we would subtract 1 from the x, and we would have to do what with the y? Subtract 4 again to give us -5. And then once we knew this point and this slope, we could have come over here and said y equals, the slope is 4x, 4 times x, and then plus -5 or just -5. So you can do it like that also. Sometimes though it's not going to be easy to do it from the table. So I recommend that you either use point slope form like we did here, or you can also use slope intercept form. Let's see how that works. So we have y equals mx plus b. We know the m is what? The slope. And that's y equals, in this case, 4x plus b. But let's say I don't know the b yet. I do know x and y. Actually, how many x and y's do I know? 4. Preston, how do you say 4? Because there's 4 entries in this table. Let's clean this back up. There's 4 entries in this table. So we have any of these points to choose from. 2, 3, 3, 7. Again, I heard somebody say ordered pairs again, and that's all these are. These are just, a table is just a way of organizing our ordered pairs. Okay? Just a way of organizing those ordered pairs. So because we have those ordered pairs, let's come put one in here for x and y. Somebody give me one of the x values. 2. So here's 4 times 2. And y is when x was 2, what was y? 3. So y goes as 3. What I don't know is the b, but I can solve for it. What do I do? Allie again?
You multiply the 4 by the 2.
Gives me 8, sure. 8 plus b, and that equals 3.
And then you subtract the 8.
No, right, exactly. Simple one-step equation. And I have that b equals -5, which is the same thing I found here. And the slope is 4, so if I go back here and put the b in, I come up with y equals, exactly, 4x plus -5, or So there's many different ways to do this. I just showed you 3 different ways, right? Let's recap. What could we do? If we have a table, what's the first step? If we have a table, the first step is to do what? Find the slope. But first, before we do that, what do we need to do with the table? If we have a table, the first thing we need to do, find its rate of change and make sure that we actually have a line, right? So determine linear relationship, right? And find the slope, because that is what determines that linear relationship, right? So you can do it two at the same time. Now we take that slope, and we have a whole table of values. So what are a couple things we can do? After we find the slope, what do we do? Say it again? Write an equation. How are we going to write an equation? What else do we need to do? We just did it twice.
We need to.
What do we take? We took 2 points to find the slope. Now we take 1 point and the slope. And what are we going to use? Point slope or? Right, point slope form or slope intercept. Okay? Either way. Either way is fine. There's just 2 different ways to do it. Like we saw up here. You could take y equals mx plus b. You could stick your m in, and then you put a point in. In this case, we used 2, 3. And we found our b value, and we went back and substituted it in, and we already knew the slope. In the other case, there wasn't so much guesswork. We just followed exactly the equation of the formula for point slope form. Right? We put our 4 in, and then we had to distribute. Right? And then we moved the 15 over so that we got all by itself the y. And again, that gave us our slope and our y-intercept. And then we ended up in slope-intercept form anyways. And that's something we're going to talk about next, is how to convert between forms.